every animation we've looked at so far has been sequential in the sense that this animation plays after this animation, plays after this animation, plays after that animation, plays after this animation, and so on and so on. And there's a lot you can do with sequential animations, but fundamentally you might want to have parallel animations where A plays in parallel with B. Okay, so there's a lot of ways that I could have implemented this, and I think the most common or most logical would be an animation operator, where we would take in the fade animation and we would take in the right animation, and then we would use an operator to combine them into a parallel animation. However, I chose to do something perhaps less common, but I think it works out in practice to be less verbose, where we'll use this thing called sticky. So we say that an animation is sticky if it is running parallel with the previous animation, but in fact that's somewhat backwards, because more commonly we'll use the sticky. It's a unary operator, so it'll take in an animation and then it'll tell the monochrome environment, hey, this right animation, I want you to play it with the previous animation in the parent vector. More often than not, all this basically just means is that this right animation will be played in parallel with the previous guy you added to the list. Theoretically, you could make the first animation in the list sticky, but that'll have no effect. Alright, so let's take a look at this. So, probably what you expected, we fade in the square, and in parallel we would write. Let's just see what this looks like non-sticky, sequentially. And then in the sticky case. Great. Okay. So I think the majority of the times, parallel animations aren't hard. Where they become hard is if we want to do parallel animations on the same variable. Alright? In many cases, parallel animations don't even make sense. For example, instead of doing fade and write on different variables, if we want to do fade and write on the same variable, like we were trying to fade and write the square, that doesn't even make sense. How can we write and fade the same object at once? So if we do this, we will get an error. We'll get an error that there's a concurrent modification. So you can get concurrent modification for a couple of reasons, even if it doesn't look like concurrent modification. But more often than not, this means that you're doing an animation in parallel with another animation that's already trying to take control of that variable. The other reasons you could possibly get it is if you just do weird stuff, such as creating an animation but not adding it to the playlist. That's somewhat unspecified behavior, and you could get weird results. But if you just do the usual stuff, you shouldn't have to worry about that. Alright, so it definitely doesn't make sense to do two animations on the same variable if we want to animate the entire thing. But what if we want to animate two subsets of the same variable? So maybe this animation and this animation, they're animating the same variable, but A animation is animating some left half of it, and B animation is animating some right half, and the sets that they're animating are disjoint. So there's technically no conflict, but if you just do it in the naive fashion, you might still get the concurrent modification because Monochrome isn't smart enough to know that you're trying to do it on different subsets. So to actually do this then, we have to be a bit smart, and the idea is pretty simple. What I'll do is I'll transfer the region that A needs into a separate variable. I'll transfer the B region that needs into another separate variable. I'll do the animations in the separate variable, and if necessary, I'll put the results back into the original list. And in this fashion, we avoid all possibilities of conflicts. Okay, let's look at an example. So here, it's pretty much what we had over here, but now that the circle is embedded within square, and I want to do a fade on one half of shapes and a write on the other half of shapes. So to do that, I'll create this first auxiliary variable, which I'll use mesh select. Mesh select is a very, very useful function. It just takes in a mesh tree and selects only a subset of it using the tag predicates. Excuse me. And similarly, we'll do the same thing for aux2. One in tag just basically means select the circle. So now I successfully separated the shapes tree into two separate trees. Technically, I haven't done a complete transfer because shapes still has its meshes. That doesn't really matter in this case, but something just to keep in mind. Now we'll do normal animation on aux1 and aux2, and at the end of it, auxiliary variables are meant to be short-lived. So auxiliary variables are important, but they're meant to be short-lived. So 99% of the time, you have to hide them at the end of their use somehow. So we'll set the auxiliary variables to be null, and then we'll show in the shapes. So by the end of it, shapes will be visible. The auxiliary variables will have gone through their entire animation, so they'll be invisible, and we'll have gotten the animation that we wanted. Okay, that was again somewhat of a toy example because we just saw that we were basically just doing this. So whenever you have a finite case, somewhat of a toy example, but whenever we have a variable case, it does get a bit more interesting. Okay, this might be a bit complicated to follow, but I'll try my best to explain. So right now I have a matrix of dots. Let's actually just see how this matrix looks like. Oops. Alright, so we just have a matrix of dots, and the tagging convention I'm going to use is that the ith row, jth column, or I suppose actually it's going to be ith column, jth row, is going to be tagged with ij. Simple, but effective. Okay, now we just did a set animation. I could just as easily do a fade animation. But what if I want to have it so that every single column appears slightly after the previous one appeared? So we can't just do a sequential animation, because if I did a sequential animation, then there would be some overlap between this showing and this showing, and then we would have the concurrent modification. But I can't do a purely parallel animation either, since if I do a purely parallel animation, then it'll just all be shown in one, right? So we have to use something called lagged map, but don't worry about it too much. It's essentially just saying do everything in parallel with some slight offset. So exactly what we want. Okay, so I want to show in every single column one by one. Now we could create 8 auxiliary variables. That'll work in this case, but that's obviously not scalable. It's obviously not ideal. So, but we'll do that, but now we'll use a for loop to help us. So what I'm going to do is I'm going to transfer this entire column to an auxiliary variable in the first iteration of our loop, and then we'll do the animation on that, and then we'll do the same thing on the second one, third one, fourth one, fifth one, and so on, do animations on that, and then once we're done, we'll transfer back. So let me explain what we have over here. So I'm not going to add it to the global play variable list yet. I'm first going to actually have the animations that I need. Sorry. I'm going to first have the animations that I need, and then I'll put it into lagged map, and that's going to handle the parallelness for us. So I can't add it to the global animations list yet. Anyways, what I'm going to do is every iteration of the loop, I'm going to create a new auxiliary variable. So even though that we only declare tree aux once in our program, it's going to be created, a new auxiliary variable is going to be created every iteration of the loop. So that's important. And the contents of this auxiliary variable are going to be exactly where we're going to take the ith column. And that's what we want, right? Now this auxiliary variable is taking control of the ith column. And then I'm just going to fade in the ith column, and once I'm done, it's important that I transfer it back to the main. This is the final dump variable. If I didn't transfer it back to the main, we would lose reference to the auxiliary variable, and if we lose reference to the auxiliary variable, the auxiliary variable is just going to be visible forever, so that's bad. So again, more often than not with auxiliary variables, they're meant to be short-lived, and after their time has served, you don't have to transfer the contents, but you probably should transfer the contents to a more permanent destination. So transfer is going to do that job for us. And if we do put it all together, what I'm going to do is I'm going to separate it all out. I'm going to separate the matrix into its 8 constituent columns, send that to 8 auxiliary variables. I'll fade in each auxiliary variable almost in parallel, but with some slight offset in between one of them, such that there's still overlap between consecutive animations, so that we can't do sequential, but we still get the effect of having some lag between them. So let's actually look at the final result. Yeah, great. Exactly what we want. Okay, and maybe we'll just play it in the editor for the sake of it. Great. And in fact, we can even generalize this pretty easily at this point to instead do something so that it's every single dot who we will transfer, make a new auxiliary variable. Auxiliary variables are somewhat cheap, so don't worry about creating too many of them. Alright, so that's the basics of parallel animation. There's one last thing I want to talk about. So remember how we showed we can do custom animations? At that point, it didn't really make sense, but we just saw over here where this was relatively complex logic. I think it's fair to say that. It's relatively complex logic, and whenever we have complex logic in monochrome, we want to abstract that away. So I'm going to create this column fade animation. So this is going to be a progressor. This is going to be a progressor because it modifies the input. Or sorry, no, actually this is not going to be, technically this is not a progressor. Even though we do some slight modifications, we're going to restore it back to the original state. I misspelled. This is not a progressor because even though we do modifications, the original state is kept. But anyways, other than that, it's going to do exactly what we have before. And even though the column fade isn't any simpler, the column fade is basically what we have over here. It's not any simpler than what we have before, but the interface is so simple. The interface is so simple, I don't even have to worry about it when I'm calling. I don't have to worry about any of it. And I just have to worry about writing this logic once, and then once I have that here, I get everything for free. So again, we get the exact same result, but hopefully you can see this is really why it's really great to be able to write your own custom animations. Progressors are a bit too, but being able to abstract this sort of logic is a huge time saver.